Hi everyone, welcome back to our project that is regarding toxic comment detection. So in this project, what we are trying to do is whenever someone puts in a comment as an input, then based on its toxicity, it is going to be flagged. And if the toxicity is low or medium, it is going to be permitted. But if it is high, then the comment is going to be either blocked or flagged in red. So that if there are any moderators, then they can specifically pay attention to those, or else it will directly block as well in an auto moderation mode. So this is the main objective of our project. Now let's look at our data set. So in our data set, we have columns like ID, comment text. If you can see here, ID, comment text. Is it toxic? Yes or no? Severe toxic? Yes or no? Obscene? Yes or no? Threat? Yes or no? Insult? Yes or no? Identity hate? Yes or no? This is what it is like. Now you can see it is yes or no. I told you right, 000. So it is like a yes or no. Now we are going to take this data and we are going to create a machine learning model out of this to predict or to detect if the given comment is toxic or not. And if it is toxic, then what is the level of toxicity? Now let's get into the model building part. Here, these are the libraries that we are going to use. We have loaded all of these libraries. Then next, in this line, we are loading the data set. We are directly loading the data set from Hugging Face. Internally, it will pull the data from the cloud and then it will cache locally and converts it to structured format. And then we are converting the data set from Hugging Face dataset format to Pandas dataset format. And here we are checking the number of rows and columns of the dataset. Then in this line of code, we are checking the number of null values. And then we are also dropping wherever we see null values because model cannot learn from empty text. And then we are performing label engineering because these are the original labels. But the thing is we have a problem of multi-label problem. So what we are doing is we are trying to check so to tackle this multi-label problem, we are going to provide some ranking to this. Here you can see this is the ranking that we are providing. These ranks are going to have levels to them, and based on those levels, labels are also being provided. Then here we are applying that function. Then these labels will have some numeric values to them as well. That is in order to perform encoding. But performing encoding is going to be, a huge process. But just assigning numeric labels like this is going to be a easier one because we don't have lots of labels here now. And we are label mapping the entire data set. Now comes the part where we are cleaning the data. So we are using regular expression, which is a library that can be used for pattern recognition. So first, whatever the text comes, we are ensuring that it is a string format. If it is not, then we are converting it. Again, we are lowering, that is, we are converting everything into lowercase. Then we are removing punctuations, numbers, and symbols in this line of code. Then in the next line of code, we are removing leading and trailing spaces or extra spaces. Now you can see here, we are applying this function and we are now checking the harassment rank distribution, like how many are falling in what rank. That is what we are checking here. Now we are converting this pandas to again Hugging Face format, but this is not, we are not going to use it later. So it's okay. We can ignore that. Then here we are looking at the value counts. That is, value counts, what it will do is it will count number of times a category is being repeated in your column and it will give you an output. Then we are plotting graphs. We are plotting this graph to check the distribution of toxicity levels in training data. And then in the next steps, again, we are comparing the model metrics just to check which model is doing best. Of course, this step is supposed to be in the end, but it is now at the top because all the data visualization is, all the visualization code is put in one place. But remember, before you go to model building, it is very important that you split your data into input variables and target variables. That is what happening here. Then you perform train test split. What is train test split is, if you train your model on your entire data, on your 100% of data, then how are you going to check your model performance? You'll need some data, right? So for that, in your training data itself, we are separating small amount of data just to check how your model is performing. Here, test size is equals to 0.2 is signifying that we are using 20% of the data for testing purpose. Then here, TF-IDF vectorizer. This is how you are converting your text data into numbers, because machine learning or deep learning, anything will happen only on numbers. It will not happen on text or letters. So we need to convert them into vectors. TF-IDF vector is one method of converting. Then after converting everything into vector format, we are building models. We are building models. We are checking their metrics or their performance. And then with this line, we are saving it. In the same way, we do check for different models. Here we are checking for naive Bayes. Then here we are checking for logistic regression. At the end, what we found out was logistic regression is the best model. So using logistic regression, we have performed hyperparameter tuning. You can see here, these are the parameters that are being used to perform hyperparameter tuning. Now, what is hyperparameter tuning is, if you build a model at its base state, that is at all the, with all the default values, if you build the model that is not suitable for all the data sets. Okay, just broadly at one point, people have decided that, hey, these values are optimized for model performance as well and for the system performance. So they have set those default values, but it is not suitable for all the data sets. So in order to make sure that the model is tuned for our data set, we have to move some knobs in the model's parameters. These are those parameters right now that we are using for our model tuning. Then we are using the grid search CV. What grid search CV will do is, it is going to check all the possible combinations in these parameters and will tell you which is the best model and what are the best parameters. Then we are saving that model. This is the model building part of this project. Then comes the model deployment. Here you can see we're just saving all the comments in a list in a session state. Now, once you hit Control plus R, that is refresh, or if you close the web page, all of them will be gone. Okay, that means we are dynamically saving everything. Now, if you want to save them in your local, you can also add a button to download your session state. That's not going to be a bad thing. Then here we are loading the model and we are caching that model for our next usage purposes. This is all the styling of the page. Then here we are writing a label logic. I guess we've already seen this label logics. Then here we are taking in input from the user, the text input, they're taking input. And then once you click on the button that is used for analysis, it is going to start the predictions. It will start the prediction and it will give you the display, that is, it is bad or is it good, how is it doing, and what is the level of toxicity that it has. It will show all of those things here. And here we have used this specific icon so that to delete any comment that is being posted. So this is how the toxic comment detection project is present. So I hope you were able to learn something and I hope you've had some valuable insights into this project. Thank you for your time and I hope you too join me in the next one.